I hope we are live. Welcome everyone. Today we are trying to do something new. We will be solving some previous year Infosys questions. Let's say this is PYQs. Okay, so we'll try. I have picked up some random questions from the internet that were asked in this company in the programming round. So I have some questions prepared. We will be solving them one by one. You can also try solving along with me, or you can pause the video if you are watching this later. Uh, so let's get started. Before starting with these PYQs, I will try to do the LeetCode POTD, so the problem of the day. So I think the problem of the day for today is easy question, even though I have not solved it before. So it says count negative numbers in a sorted matrix. So basically it's a m by n matrix which is sorted, ordered row wise and column wise. Return the number of negative numbers in the grid. Okay, yes, there is of course the brute force way, and it will get accepted that 100 cross 100 is the given constraints, so it will definitely get accepted. But I want to make use of the fact that they are sorted by row and column, right? Okay, let's go back to the iPad and let's say if you can try to make use of that fact somehow, even though it's not required for this question. But and it says yes, if you could find an order of m plus n solution. So basically I want to find, yeah, of course, order of m plus n, not mn. So mn solution is extremely easy. So m plus n solution, since it's sorted, we will try. I hope I am audible. Let's see. Okay, thank you very much for subscribing. Okay, I think it's running well. Okay, that's enough. So let's go back to the iPad. Let's see. So we have a matrix, right? So A, B, C, D. Let's say use general notation A11, A12, A13, dot 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 A1. Okay, number of columns are told, right? Number of columns are n. So A1n, right? And A21, A22 to A2n, and the number of rows are m, so A1m, this will be M1, M2, AMN. I hope I am clear with the notation. Just think about these are n in number, so n columns, and these are n m rows. Okay, so I know that they are sorted in both column fashion and row fashion. So I can say that let's try to repeat this. So I know that if the negative numbers are existing, it will be around these regions. Like, let's say I have some, they are sorted through rows. That means A11, A12, this is bigger, sorry, this is bigger, this is bigger, A1n. So A1n is smaller than the previous one. I also know that A21, A11 is greater than A21. So it's like if you think of it some sort of flow, then this is the biggest number. This is smaller, this is smaller. And so if say this is the first negative number, let's say Aij. I know that the numbers after this will all be negative. And after below this will all be negative. Right? Okay. I hope that makes sense. So there is a middle point somewhere where the first negative number is. Let's say this number is maybe positive or 0. Let's say greater than equal to 0. This will also be greater than equal to 0. Question is, can this number be negative? Let's think. I am bound to know that, let's say this is an array. And let's say at this point it's a negative number. Right? So I know that all of these are negative by default. If this is negative, I know that all of these are negative. The question is, can any region in this part be negative? I think it's possible, because if this is negative, let's say I know that this is greater than equal to 0. This is greater than equal to 0. Let's assume that this is the section I have already assumed is greater than equal to 0, and I have come down and say it's negative. And let's say here it can be negative, right? So I'm thinking that there is a specific section, I don't know, it can be greater, longer, it doesn't necessarily have to be good square fashion. It can have any type of shape, right? So all of these are negative and all of these are greater than equal to 0. And let's say this is the big matrix, right? Now it says, I will write down the MN code, M cross N code, that will just brute force and check for every number if it is negative or not. But I'm trying to arrive at the order of M plus N solution. So basically I will try to maybe scan one row multiple times, constant number of times, like twice or thrice. Also this thing I will try to scan once or twice or thrice, but a finite number of times that is independent of N and M. Well, that will give me the complexity of order of M plus N, right? Since the array is sorted, one way to find the first negative number or 0 in a particular row is by binary search. So let's say I am on a particular, this is a matrix, and let's say I am on this row and I want to know that how many negative numbers are on this row. So one way is, let's say these are the numbers, say this is, so let's say I apply a binary search on this for 0, and let's say I don't find any 0. That means either all the numbers are positive or all the numbers are negative, right? If I don't find a 0, then I will check the first element. If it is negative, then I know that all the numbers are negative. If I don't find a 0 and let's say the first element is positive, then every number is positive. Let's say I found a 0. That was the case 1, that I don't find any 0. Case 2 would be, let's say I find a 0 at some uh, uh, A P. That means all the numbers that are on the right of AP are zero, are negative. So basically I want to find the last occurrence of 0, not the first occurrence. So I will try upper bound. Like there can be duplicate zeros as well. Or I think they have told that all the numbers are distinct. Are they? No, non-increasing order, both row wise and column wise. So I think there can be repetitions, so we cannot trust them. So if there are multiple zeros, we will try to find the last 0 by using upper bound and check for. So this gives me a solution of order of log of uh, n, I think n is the number of columns, right, into how many times am I applying log n? M number of times. So this is order of m log n, right? This is an acceptable solution. Of course, this is an easy question, so any of them is acceptable. So this is an m log n solution using binary search, since I know that array is sorted. So I have only used the fact that the arrays are sorted row wise. I have not used the fact that they are also sorted column wise, right? So let's try to think of some solution, kind of a 2D binary search situation. I'm thinking like that will let me use both of the facts. Okay, let's see. I hope my iPad is visible. Let's try. Let's say I know that why my headphone, is my headphone working? Can I think of some two-pointer approach? Like I will increase one of them as long as it's positive. And let's say I reached a point. Let's take a test case and see. It's a 4, 3, 2, minus 1, 3, 2, 1, minus 1, 1, 1, minus 1, minus 2, minus 1, minus 1, minus 2, 3. Okay, am I still live? Yes. Where's my iPad? Yes. So this is the copied question. Let's see. Let's say I start from here. Let's say I started going. Let's say I have another pointer somewhere. So there has to be a 2D binary search kind of thing. Let's say I select a random middle point, this. Okay, will this be the middle point? No. L by 2 and M by 2. So basically floor of L, N by 2, comma M by 2. Sorry, M by 2, comma L by 2. It doesn't matter. And let's say I check this. And let's say I find a positive. So that means, no, but that will only help me to find this point. But still that doesn't give me enough information to okay, let's think of some idea. Let's say I am at this point and let's say this is positive. The question, if this is positive and let's say I'm also, I hope I'm visible, and let's say I'm also here. Yes, so let's say I choose this point and this is positive. That means all of these are positive. So I will go to the next step, I think. Or should I go top? I'm trying to scale it up. Like, let's say I will have this grid, right? That will consist of negative numbers. I'm trying to start off here and I want to go like this. I know if I know this point, so I know the boundary of the, what should I say? I know the boundary of this negative person. So I know that how many are in this direction. And let's say I know this boundary. I know that how many are in this direction, how many are in this direction. So I'm trying to find the boundary. Okay. Let's say I start from this position. So there can be two cases. Either it's negative or it's greater than equal to 0. Let's say this is negative. So that means this is a boundary. If this is a boundary, all of these are negative. So I can add to my count. Let's say this is, I can also start from this direction as well. It really doesn't matter. It doesn't matter, let's start somewhere at least. So count plus equal to this, let's say, initially I have to start from the bottom left or the top right. Because, and I will try to find the boundary along that. So count plus equal to, let's say this is m minus 1, right? And this is 0. If this is m minus 1, So m, so count plus equal to m. This is the row, right? And column I, let's say it's equal to 0. But what if I don't find this to be positive? Let's say I found this to be positive. If this is positive, then all of these are positive. So I have to go in this direction. So C will increase by 2. So I can just say if grid of R comma C is greater than equal to 0, that means you did not get anything. So let's increase the C column. Else, I know that I have found some number of answers. How many I have found? I think I found m minus c. Yes, so let's say answer plus equal to l minus c. Maybe, let's say if this is negative, right? Let's say in some place this is a stair. So I have come on top. That only means that this must be positive. Because if it were negative, no, I mean the bottom was one negative, right? If this was negative only, that means I expect to find more answers along this row. So that's why I have come. If this were positive, I know that all the top ones are also positive. So I should have gone this way. So from this is negative, this I have found to be negative. So it's like grid of, so it's negative. So count I have increased this. So, and I am doing, I think R minus minus, right? I think that should work. So I'm working on the boundary. Okay, this looks like a good solution. Just for sake, let's try submitting this and we'll try to form the same boundary in a different fashion. Like we started from bottom left, we'll try from the top right as well. So initially I think we was on the bottom left. So n, I think it's m by n. So m is equals to okay. So now we want the pointer. So int p1 to be the row pointer to be on the bottom. So m minus 1, and p2, which is the column pointer. Let's say this is called, let's say is rp for row pointer, and let's see this is cp for not comparative programming column pointer. So let's set it to 0. So now I think we have discussed, I hope this is okay. I think we have discussed that these are the conditions, but when should I stop this condition? Well, starting, I cannot go on forever. Should I stop when R and C goes out of bounds? Is there any way that I will miss any point if I go out of bound? Let's say I have a negative here, that's why I went here, right? So if it were a positive, there is no point of going up, it will still be positive. It's a negative, I went here, so I will find more answers. Otherwise it's a ceiling, so cannot find any more answers. If it is a positive, so I will not find any answers on top, so I'm going here. Let's say if this is the boundary, then there is no point of me finding any more answers anywhere. Like if this is positive, I know all of these are positive. This may be negative, but we don't care. So there is no answers on the top and we are on the right. So yes, there will not be any more solution based on the operations we have performed. So we can just say if, while R is within bounds, RP, I think we are always subtracting row pointer, right? So we should have a lower bound and the CP should have an upper bound. Greater than equal to, sorry, less than equal to, less than M, let's say. Now we check if is greater than equal to 0, so it's positive. So if I'm at a positive point, the upper one is definitely positive. I don't get any answers, I just go the left, so I increase the column pointer. Else if it is negative, so I can find more answers, and this is also negative, so the entire row is covered. So I think I should have to result equal to what should I say, equal to 0 and result plus equal to the number of somewhere here, and I am on RP comma CP, and this is how many? N, right? So N minus CP. And I will, since this is negative, that means I have more possible answers. So maybe go on top. I'm not going left and right because we are covering all grounds. Like if it is a positive, there is no possible answers on top. That's why we're going. If it's a negative, we have already calculated for every negative things if it had occurred on bottom. Let's try this. It's giving me some hand gesture suggestions. Okay, it is not freed, it's grid. Okay, let's try submitting this. Okay, the 100%. Let's try to do it the other way. What if I start from the top right now? So the top right is n minus 1, right? And the column pointer would be, no, the top pointer, the row will now be 0, and the column pointer would be n minus 1. Let's say I find something that is positive. If this is positive, let's say on some point I know that this is positive and I want to travel in this direction. If this is positive, I know that all the elements on the top are also positive and all the elements on this side is also positive. So it's better for me to come down. So I should do RP plus plus. And if it is a negative, that means I should add all these answers. N minus, still the column pointer, But in this case, I should add the column pointer because I'm counting row wise. I can also count column wise as well. Like for example, let me get to the iPad, and let's say I am on this location, right? We're starting here and we'll try to travel. Let's say on this is a point. So this is an intermediary point. This is an intermediary point because all of these are positive. All of these are positive. I can either count these people and come down. Wait, am I sure that these are, if the top ones are positive? Because let's say I'm starting here, and let's say this comes out to be positive. That means all the left ones are positive. If this is a negative, I know that all the bottom ones are negative. I'm not sure if these are negative or not. So I have to count column wise then. Right? Okay. So if it is a positive, I know all of these are positive, so I should increase the row. If it is negative, so I'm sure that all the bottom people are negative. Can't say about anything on this side, on the left side. So I should do number of rows minus row pointer. Number of rows is m minus the row pointer, and I should decrease the column pointer. Of course, the conditions will change because row pointer is increasing, so RP must be less than M and CP must be greater than equal to 0. I hope this will also pass. Okay, it's directly passing. Let's see. Okay, accepted again. Okay, I will try to explain my point of view. So I understand that from this grid there is some sort of staircase going on, such that all of these elements are greater than equal to 0 and all of these elements are less than 0. So we are traveling along this staircase knowing the property that it's sorted column wise and row wise. And using that fact to guide ourselves. So let me explain the first one. Let's say at this point, I found this to be positive. This tells me that all the top ones are also positive. Yes, all the left ones are also positive. But what I'm definitely sure that since this is sorted column wise, I know that all the top people are positive. And all the bottom people, I'm not sure. Because positive, maybe some more positives are there, and then maybe negative starts. But I do know that all the people above this and here are all positive, right? So I have two options. Either I can go this side or go bottom, but we are trying to find the best case scenario. So rather than going bottom, since we are trying to travel this way, we are traveling this way, right? Maybe expect something better. So let's say I found this to be negative. What does that tell me? That tells me that all of these are negative, right? Does it tell me that all of these are negative as well? No. Does it tell me that all of these are negative? Yes. But we are trying to travel this way. But we are trying to find the boundary. Like if this is positive, I want to find the negative people. I know if I go top, I will always tend to find positive. But maybe if I go right, I will find some negative person. So boundary that will help me count the rest. I hope you understand. Try to think about it a little. Okay, let's see if the live stream is going on well. So boundary that will help me count the rest. I hope you understand. Try to think about it a little. Okay, it's running well. So I think I've solved this in 2 ways. I think I have 2 submissions. I will post these solutions. Since this is an easy question, it's not really important. It's not expected much out of us. It will pass for order of MN as well. Like it's a 10 to the power 2 into 10 to the power 2. So it's a 10 to the power 4. It will pass for 10 to the power. It will pass for MN. It will also pass if it is 1000 into 1000. So 10 to the power 6. It will pass. But the solution we have written is order of m plus n. And that will pass for m comma n if it is up to 10 to the power 5, which will fail here. By 10 to the power 5 into 10 to the power 5 is 10 to the power 10. It will fail if it is mn. But m plus n, it will not fail. If it is 10 to the power 5 or maybe 10 to the power 6, it will not fail if time limit is 1 second. Okay, I hope you understood. Let's get to the agenda of our late night stream, that is Infosys PYQs questions. I've collected some random questions and I will try to solve those. So let's start with the first question. You are given a string number representing a positive integer and a character. Return the resulting number after removing exactly one occurrence of the digit from the number such that the value of the resulting string in decimal form is maximized. Okay, so let's say I have an input. Let's say x is an input. And let's say 2, 1, 2, 3, 1, 4, 7, 6, 1, 2, 3. Now let's say I want to remove 1. Okay, so I can either remove this one, I can remove this one, I can remove this one. So whichever one I remove, I want to result to the maximum. Like if I remove the first one, the answer, it will become 2, 3, 1, 4, 7, 6, 1, 2, 3. This is the number, resultant number form. If I decide to remove the second one, it will be 1, 2, 3, 4, 7, 6, 1, 2, 3. So this is smaller than this number. So this is probably the best we have found until now. Even if I remove the third one, it will still start with 1. But let's consider this case. 7, 1, 2, 3, 4, 7, 6, let's say input n is equal to this. Now let's say this is also 1. If I decide to remove the first one, it will be 7, 2, 3, 1, blah blah blah. But if I decide to remove the second one, it will be 7, 1, 2, 3. So removing the first one is more. Let's try to make a case where removing the other ones is more beneficial. Let's say the n is, let's say I want to remove this 2 character. So if I decide to remove this 2, and let's say there is a 5 here. So the 5 will come up 7, 5. If I don't remove this 2 and maybe remove this 2, let's say remove 9. So there is a 9 here, there is a 9 here. Okay, so if I decide to remove the first 9, it is 7, 5, 3, 4. If I decide to remove the second 9, then it's 7, 9, 5, 3. So it's better for me to remove the second 9 to result to the maximal number. I hope you understand. So we are trying to remove the occurrence of the digit from that number such that the resultant number is maximized. The constants are not given, but I will give you the constants. Like let's assume that n is up to n as a digit. We need to perform comparisons of digits, and we cannot really compare two strings, but we can. So if n is up to 10 to the power, am I visible? So if n is up to, there can be multiple parts. Since this is an Infosys question, I'm not guessing that this will be very hard. Like there are possible solutions. Like n can be up to 10 to the power 5. So any order n will be accepted. But we need maps as well in order to maybe store the elements indices, and then maybe generate strings maybe. So let's say I decide to remove a particular character, so I have to form the number. So I have to take the string before me, the string after me, join them and store it into some, and compare it with my compare that to my already existing number. If it is greater than that, so replace that with my new number, right? So forming substrings is at every point I find that occurrence. So that's an n square operation, and like it's an order n operation. So at every point, let's say I find some character that I want to remove. So on that character, I have to form a new string by removing that middle character. That is an n square operation. So n can be up to 10 to the power 3 then. Otherwise, is there some string algorithm I can use? If n is up to 10 to the power 3, what is the input size given? It's up to 321. So no, n is up to 10 to the power, let's say 10 to the power 4, even if it is 10 to the power 4. I don't think substring will cause that much trouble. Concat two strings. I think it's an order n. It can be solved by order n. So n can be up to 10 to the power 5. But I'm thinking that this can be easily solved. That's not the issue. I'm thinking about, can n be up to 10 to the power, I don't know, 10 to the power 5? Like, can the string be of 10 to the power 5 digits? I think it can be. Like, if the substrings can be made in constant time after removing those characters, and we do know how to compare two strings, but in order to compare two strings, I need at least order n operation. Two strings cannot be compared in constant time. No, this will not work if it is 10 to the power 5. Because if it's a big string and I want to compare that string to some other big string, it will take, I have to check which is lexicographically greater, and that will cause an order n operation. And I may have to do it a lot of times. For example, let's say the n is 9, 9, 9, 9, 9, and let's say remove 9. So I can either remove the first 9 or the second 9 or the third 9. So at every point I am making substrings and comparing it to the original. And there is no smart way to maybe get around it. Am I still... Okay, let's see. Maybe get around it. Okay. So we will just assume that n is up to 10 to the power 5 for this question. Let's try to solve this. I will be using normal VS Code because it was asked some. Let's forget this. Okay, file open. Okay, let's make a new file. Main.cpp. I will solve it in main.cpp. Let's delete the test cases. So we are trying to input a number, right? Let's use the default template. Even though I have big templates, let's ignore the template part for now. So what we are doing, we are inputting a string s, scene s. Try to focus on the logic part rather than the template of this code. And we are trying to remove, and so of course there is a character x, and let's say we're going to form the largest. So the string can be up to 10 to the power 5, right? I mean, the number can be up to 10 to the power 5. So of course it can be stored in an integer very easily. So let's say long not required. So int result equal to, let's say 0, and say I will loop through this n, where n is the size. So if I see that if s of I is the character that I am expecting, I want to remove, so I will try to form a number out of it. So string number is equals to, first I need to find the substring, right? So from 0, so s.substr, I will start from 0, and I want the size. So the x, I think it will work. Like if x is, I, let's say if I is 5, that means I'm on the 6th character. So I want 5 characters, 0, 1, 2, 3, 4, plus s.substr, I think I plus 1. And if I don't give second argument, it will take until the end of the string. And let's say result equals to max result, comma, I think the integer version, I think stoi of number. Okay, it says max. Okay, argument times are long. I will just remove this int equal to long part, and in the end I will just print result. So let's 1 3 3 1, and I want to move. What was the test case given in the question? 1 3 2 1. Let's try running this. Do we have test cases? No. Okay, wait, I think string s, scene s, characters s. Okay, 3 to 1 has been printed 4 times. I don't know why. Okay, I think I've done a mistake here. This will be the case. Okay, 3 to 1 has been printed. Let's try to run it on the other test case that we have formed at 7.9 thing. 7953. 7953. It can be up to 5 digits only, so 962 maybe. And let's say I want to remove 9. So I have two options. Removing the second 9 is better. Yes, so as you can see that the second 9 has been removed. Okay, that's I think does it for this question. I hope you understood the logic. So we are checking if the character is equal, we are forming a number, and we will max it out with the currently available number that we have. There are no concept of negative numbers here, so we can go to the next question. Okay, next question is, I think there is a printing mistake. It should the fourth condition is nums of 2i plus 1. Okay, so how can I mark this? So the fourth condition is nums of 2i plus 1. I will write down all those conditions. I will just read the question. So first we are given a zero based so we are given an integer n. We want to form a array of size n plus 1, and it has told us that nums of 0 will be 0, nums of 1 will be 1, nums of 2i is just nums of I, and nums of 2i plus 1 is just nums of I plus nums of I plus 1, where 2i plus 1 forms in this range. 2i, we know that it represents even numbers. 2i plus 1 represents odd number. I will write down this condition like nums of I plus 1, and nums of, is a printing mistake, 2i equal to nums of I. So these are the first conditions, and nums of 0 equal to 0, nums of 1 is just 1. Cool. So it's just a way of finding a pattern. So 2i plus 1 means odd, and 2i means even. So we will try to think that first we put I equal to 0. We already know. If let's say I equal to, okay, let's say, so I will be either 0, we already know. I can be 1, we already know. I can be 2. So 2 can be represented with this formula such that I is equal to 1 in this formula, right? If I is 1, that tells me that nums of 2 should be nums of 1, and nums of 1 is 1. So nums of 1 should be, sorry, nums of 2 should be nums of 1, that is 1. What about nums of 3? Nums of 3 can be represented as, if I put I is equal to 1 on this formula, it will give me nums of 3 is equal to nums of 1 plus nums of 2. So let's see if you can form a pattern. So n of 0, short form for nums, equal to 0. N of 1 is equals to 1. N of 2 is equals to n of 1. And n of 3 is equals to n of 1 plus n of 2. What about n of 4? N of 4 is even, so it should be n of 2. N of 5 is odd, so it should be, what the value of I should I put? I think I should put n is equal to 5, right? So I think I should put 2. So n of 2 plus n of 3. So can I say that if I is odd, the first index will be I by 2, floor division, and the next is I by 2, seal division. So this is I by 2 floor division, and this is I by 2 seal division, considering that this is I. And for even, I can just say that it is I floor division. Of course, if it's even, so there is no difference in floor and seal division. I hope you understand. So we will just use this formula, that's it. So for the first two you already know, and I think the constraints are n is at least 3. No, nothing is being told. Let's assume that n is up to 3, right? No, but let's say n is 2, then 3 size array I will make. Okay, doesn't matter much. Only the logic part is important. So I will replace, should I make a new file out of this? Let's call this P1. Let's say Infosys. And let's say make a new file P2. All of this will be available in my GitHub. At least the ones that we are doing here. So what do we have for P2 Infosys? So what we have is, so we input an n, right? And we are trying to make a size of n plus 1 size. So I know that if n equal to 1, so 1 size array, so I just print, that's a 0, that's it, right? If n is 2, print 1, sorry, 0, and then a space, and then a 1. It's a space, right? So but if n is 3, we already have to declare a 2 size array, right? Let's make a new array, v of size n plus 1, and I will say that v0 equal to 0 and v1 is 1. For 2, I will start making amends. It is of size n plus 1, so it can go up to index n, right? So if I is even, so yes, so if I and 1 means it's odd, let's do it the normal way, mod 2, so it's even, so I will just do v of I will be v of I by 2, else v of I will be v of I by 2 and I by 2 plus 1. Let's try to print v. So we input an n, so let's say n equal to 5. Okay, so it's give me 0, 1, 1, 2, 1, 3. Let's see if it follows my follows the conditions that are given in the question. Let's try to for a bigger number, so let's say n equal to 4, let's say n equal to 5, let's say n equal to 10. Let's run all of them. Where is my pen? Yes. Let's go back to the iPad and let's see. So for n is equal to uh, yes, for n equal to 4, we know the first two elements are 0 and 1, and this is index 0, this is index 1, this is index 2, that is even, so it should be I of 1, so 1 expected. Next index is 3, so it should be I by 2 this plus this, so 2 plus 1 3. Wait, no, that's not happening, is it? So if I is odd, it's I by 2. Wait, yes, it's 2 plus 1, sorry, 1 plus 1 is 2, it's correct. And let's say I equal to 4, so 4 should be 2, so 1 again. If I is 5, so 5 by 2 is 2 and 3, so it should be 3. Yes, it's expected in the next question. I think it's correct. I hope you understood. So that will be for this question. Let's go to the next question. I think I can close this one. Okay, the next question is, you are given an array which has n integers. You want to construct a new arrays using ARR using the following algorithm. Okay, a big question. Initial result is empty. Start at any index of ARR. Choose the direction left or right. Iterate over elements of ARR starting from the chosen index in the chosen direction. At each iteration, as each iteration element to the end of the race. Okay, this means that after the last element, you iterate to the first one and vice versa. The value of race is the sum of bitwise of all the prefixes of it. That means the value of race can be thought of as race 0 plus race 1. Okay. Okay. So we start at any index of ARR and we go to any direction. So let's say I have this ARR array A1, A2, A3, AN, and res is empty, right? And we say that start at any index of ARR. Let's start at A3, and we can go left or right and iterate over the elements as each and add each iteration element to the end of the RES. We understand that the add each iteration element to the end of RES. But then the RES will get too big. No test cases are given for this. Can I find this question somewhere? Let's skip this question for now. Let's do the next question. I don't really understand this question. Okay, you're given an array and you have to perform a specific task given array length is greater than 1. So, okay. So basically an array is given. If two elements are different, you can remove both of them in one operation. If they are same, you cannot remove them in two operations. So what is the minimum number of operations to remove all the elements? So as long as we have two different elements, we can remove both of them in one operation. So we will always try to pair of two different elements. So let's say the input is given 1, 2, 2 are different. Let's say 2, 2, 3, 3, 1. Okay, so let's say this is given as the array. So if we remove these two, good, these two, one operation and one, so three operation. Sorting them makes our life easier, like 1, 2, 2, 3, 3. Like if it's sorted, I know that the last two elements will either be different, or if they are equal, then I know that in the middle people are all equal, right? So if I sort them and I pick the last two, the first and the last element, if they are different, that means I can remove both of them. If they are same, that means all the middle ones are also same. So that will cause operation of this, then shrink, right? So that's it for the solution. Let's see. Let's make a new file, p3.infosys. No, it should be p4. So let's say we input, I think we input just an array, right? Int n, cnn, of size n. Let's say we input the vector somehow. Let's do it normally. Okay, now we want to sort this. So now we say, so we have two pointers on the first and on the last. So p1 comma p2, one is on the 0 and one is on n minus 1, while p1 is less than equal to p2. If, okay, I think I'm running out of charge. Let me put my laptop on charge. Okay, so if okay, v of p1 is not equal to p of p2, that means I can remove both of them in one operation. Let's say int operations equal to 0. Plus plus, and then I can do p1 plus plus comma p2 minus minus. All of this will work together, right? Next, if they are equal, that means we have already reached a place where, so else I will just say operations plus equal to p2 minus p1 plus 1, and then we break. I'm telling you why this is the case. So let's say we are at two indices and I know all of them are equal, so I have to remove them one by one, and between two indices, including both of them, the number of elements is this index minus this index plus 1. It's like how many elements between 5 and 1, including 5th and 1th itself. So it's 5 minus 1, that is 4, plus 1, because we are including both of the boundaries. So we print operations. Okay, let's, any error, let's remove this one. Let's say int n, and let's give it this input that we have in the iPad, 1 2 2, let's say 2 2 3 3 1. It should give us 3 operations. Yes, 3 operations. So I hope you understand. This code will be again available on my GitHub, same name as the YouTube channel, after the stream ends. Okay, let's go to the next question. So now we have an RPG game. So one of the hardest quests, let's see. There are n monsters and you will need to defeat each. Defeat in the quests. Every monster comes with a power eye and a bonus eye. Okay. So I can only I have enough power and I will gain the experience. Okay. So I do have the choice. You can pause and read the question for some time. We can defeat the monsters if we have enough experience points, and once we defeat the monster, we gain its bonus points, and that add to my experience points. Okay, first line is the number of monsters, second line is the initial experience points, the third line is, so I can just sort the monsters' powers with respect to their strengths, and we will go one by one. So why I'm thinking like this is, let's say it's not really affecting me to defeat the bigger monster first and smaller monster later. It's not, if I have enough power, I can just defeat it without spending anything of my own. So it's not a DP based problem, that maybe if I defeat that monster first, I will lose some points, and if I don't defeat, I may gain some points. So there is a trade-off. So order of defeating the monster is important. But if you read this question, you will see that it doesn't matter. As long as I have enough points, I can just defeat any number of monsters with that points and gain the experience, so that I can maybe defeat harder monsters later. Okay, so let's go to the VS Code. It will be P5, right? Okay, so we have int n, which is the number of monsters, then int initial executive lines containing integer and bonus I. Okay, first I contain all the powers. So of size n, pi exp of size n again, and I can just input both of them. Ignore the fast input part. Now I will sort them with respect, but if I am deciding to sort any two powers, their experiences will also get what should I say, interchanged, right? So I cannot just perform a sort directly. I just have to think like, okay, was my leg visible? Okay, a little embarrassing, but yeah, the leg was visible. Anyways, it was a knee anyway. Is my live stream running well? The leg was visible. Anyways, it was a knee anyway. Okay, so we have the powers in the XP and we want to sort them with respect to powers. But we also want the XPs to be in a line. So we have to form a pairs. So let's say PE of size n again. So for let's say just 4 then, and I can just say PE of I equal to a pair of powers of I and XP of I. Okay, so now we have pairs. Now we want to sort them, right? We want to sort the pairs so we want it ascending in terms of powers, but if two monsters have same powers, we can do it descending in terms of XP, but think that if I can defeat this monster, if some equal power monster comes later, I will definitely be able to do it. But let's do it descending in terms of XP anyways, so that you understand how to do it in ascending and descending order. The trick is, the one you want ascending, you insert it normally, but the one you want descending, you put a minus sign. So what happens is, -1, minus in ascending means let's say minus in descending means, let's say there is 1 2 3 4 5. In ascending order it will be 1 2 3 4 5, but if you put a minus sign, it will be -5 -4 -3 -2 -1. So descending, ignoring the minus, of course. So now we sort, because by default it does ascending. If those two are equal, then ascending on the next part. Now we go through it one by one. If A is less than equal to my init experience, let's say experience init xp, if xp, so minus of b, okay, let's say x, so the capital, right? Okay, this one should be first. And this is not working. Vector of pair of, okay, let's say this is int. Let's forget this one. Let's set this print p. Let's make a new test case. We'll use the one that is given in the 2, 1, 2, 3, 78. Then we have 130, 10, 0. Wait. XP equal to init XP. What's wrong with that? Conflicting data types. Why? Okay, this will not be experience. EXPE, let's say. This should be okay now. Yeah, one is a vector and one is not a vector. Okay, I think AB will work now. A is less than, so B. But it's still not working. Should put an AND, even though that should not cause any problem. Okay, EXPE, sorry. Then I can do EXPE less than minus equal to B. Else break, and of course monsters plus plus. Well, even monster skilled plus plus. Monsters equal to 0. And in the end we print monsters. I don't need to print this pairs. So I think it should be 2. Yes. I hope you understand the logic. So basically what we are doing is sorting them based on monsters, powers of monster, and in descending order of experience. Even though for this question it doesn't matter if the experience is sorted in reversed order or any order for that matter, because if I can defeat monster I will be able to defeat monster I plus 1 provided that they have the same power. And I'm just checking that if initially I have some experience, if the lowest monster I can defeat, I add the experience part. I'm doing minus equal to because the experiences are all negative, so minus equal to means it will get added up, and I'm adding up monsters. At any point, if it is I'm not being able to defeat some particular monster, there is no way I'm defeating any of the rest of the monsters, so we just break. I hope you understand. There's a little error on this question. Let's try to solve the next question. Okay. So I will give you some time to read this question. Basically what it says is we want to convert an integer to a base and say the minimum base such that all the digits, let's say I have an integer n and I convert that to some number system of base b. Now I want all the digits of my representation of original number in that base to be equal, and I want the minimum base. Let's take an example. Let's say a value of the number is m is equals to 41. So we will try every base. Base equal to 1, base equal to 2, base equal to 3. We will try one by one. In base 1, it's not possible to represent because there is a 4. In base 2, we can represent it. Yes, oh sorry, in base 1 also you can represent. In base 1, what will happen? You will just write 41 ones. Right, that's how base 1 is defined, right? So base 1 of a particular number is just that many number of ones. In base 2 binary, we do 41 to divide. There is a way, or there is a way of assigning weights, like 41 can be represented as 32 plus 8 plus 1. So this is I think this is the 5th power, this is the 3rd power, this is the 0th power. So 0, 1, 2, 3. So this is the base 2. But you see in base 2, not all the digits are equal. Some are zeros, some are ones. So we want to get this number 41 represented in some base such that 41 in that base, let's say, represents some numbers. It is a sequence of numbers and all of them are equal. In this question it says that 41 in base 40, okay, if it is base 10, it is 1 in base 40. Let's check. Yes, it will be, because you see 40 to the power 0 plus 40 to the power 1 is 41, right? So this is 0, this is 1. So you understand this is 11 in base 40, and you see both the digits are equal. Any number of digits it can have, but all of them has to be equal. So the approach I will use to solve this problem is try every base. I think there is a constraint on m up to 10 to the power 12. I will try every base. I will convert that number to every base. Converting a number to a particular base is logarithmic operation to that base. So if I want to convert a number n to base d, that will be log, the time complexity will be log m base b. So I have a number m in base 10, I want to convert it to some base b. B is of course greater than 1. So this conversion takes log m base b. We are dividing by b every time. That's how you can think. As b gets larger, it's a very simple operation. So it is up to 10 to the power 12. The question is, will this fit? So it's like first we will try log 2 operations to see if it is fits in log 3 operations. Okay, let me show you the iPad. So let's say I try to represent this number in log base 2. That will be log m base 2. Let's say I want to represent this number in log base 3. It will be log m base 3 plus log m base 4 plus dot dot dot. Let's say even the last number, log m base m. You see, log m base m is just 1. So there is only one number. So we want to find the minimum. We will stop anywhere at any point. I want to know the sum of this. Log a plus log b plus log c. The bases are different. I know that if bases are high, the value is less. So I can just say that this is less than equal to log 2 base m plus log 2 base m plus log 2 base m plus dot 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 log m base m. Sorry, log 2 base m plus dot 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 log 2 base m again. How many times? M number of times. Smaller the base, bigger the log value of that number, right? So I can just say that m into log 2 base m. So it's order of m log m. But you see that m is up to 10 to the power 12, right? So m log m is not good enough. But the thing is, this will not be m log m. This is much smaller than m log m. How to show this? And I also know that this sequence is greater than equal to if all of them are m. If all of them are m, and if the base is bigger than the number itself, then I think it's very minute fractional powers. So it's 1 plus some fraction. So it's constant almost. We have to prove somehow that before m, I mean, we will get to the answer much before m. We don't have to check up to base m. So we will brute force this test case. Let's try. N is up to 10 to the power 12, so it has to be long, right? So in order to find the representation of that number in some particular base I, let's say let's set uh, I will just print I and then return. So this is much faster. Like as soon as I find a different, oh sorry, it should be insert, not pushback. So every time I find any different digit, breakout. So this it does a lot of pruning. So let's try 41. The minimum base should be 40. Yes, let's try 10 to the power 12. Like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the minimum base? 10. So we will try to brute force this now. So I will make a test case and I will do it for 10 to the power 12. So this and a lot more. So let's generate those test cases. It's a test cases. So I will just start from this. I will stop at maybe one less than this, one less digit, or let's say two less digits. So one less digit, see out I. Will that be truncated? That's all I want to see. Yes, it's truncated. Too many digits. Minus, let's say 10 to the power. Let's print 10 to the power 5 digits, okay? Stop. Okay, 10 to the power 4 maybe. Let's still be truncated. Oh, come on. 10 to the power 3. Come on, you can at least print 10 to the power 3 integers, right? Yes. So let's copy this. And let's say for this, so I have 10 to the power 3 test cases. And these are this. So I will check if it fails. Oh, of course I will be noting down the time. I'm taking a very short break of around 1 minute. I'm coming. coming back. Okay, it's producing a runtime error, or it's timing out. Can I change the timeout? CPH. Its millisecond is 10 seconds. Let's give it 100 seconds. Antivirus, I don't think it's causing that. Let's try less than 1000. Let's try 50 test cases. Okay, if even 50 cases are causing a problem, what about 10 cases? That should not really cause a problem. Come on. One case. 10. 2 cases. Okay, this one is a big. 3 cases. Okay, so the third one is a bummer. So 1. Let's forget about. We don't want to run the first case. We just want to run the second case. Okay, this is a value 1 2 3 4 5 6 7 8 9 10. So 10 digits means it's less than 10 to the power 12, and it's causing a sick term. So if it's not enough to have 10 digits and still do this, right? Yeah, so we were kind of correct that. Wait. This should be in this. Come on. Right? Is it faster now? Yeah. Let's try 1000 now. That's what I thought. That the answer is just 2 for a lot of integers. That means it is probably faster than what we expected. Maybe try a bigger number. Let's put another 9. Still fast. Extremely fast, like not even half a second. And that's for 1000 test cases. Like for one case, it can be a weird number, I think. Can I think of that weird number? That will be different in. I think there's a test case file. Yeah, so let's output it to some file. Or maybe use the terminal. Let's update my sys. Okay, so maybe do it for 10 to the power 5 digits. No, not index.ds. Let's turn on autosave. Yeah, so I want to run this, right? So what is my current directory? I'm inside cpp, right? So cd, so first see what files do I have. Okay, so g++, I want test cases.cpp, right? And I want the output. It doesn't matter where the output is. Okay. Let's try to output a file. Let's perform a Google search. How to output CPP. It's a free open file. Not here. I think I want to know. Just want to not read a file. Take input from. Yeah, fstream. No, not fstream. Let's free pen whatever. Not this. There should be a free open thing. IO from file, right? No. Like he has not defined IO from file, right? Okay, yes, this was what I was looking for. Yeah. So okay, why is this not defined? Like anything else is there? But this is just my stream. There's no storage class. Let's do it before. I think I can just do it inside the main, right? Okay, so now I think I'll be outputting just a file. Txt, and let's say input.txt. Yes, I think there is the test cases. Too many files. P6, P5. Okay, P6 we are solving, I think. Okay, I will open this up later. Let's go close tabs. Okay, so let's run this. I hope we'll be populating this output. No output. .txt. Let's run this. No output. What about 5? There's no output, of course. Okay, in input, if I put some out sort of data, 5, like maybe. There's no output. What if I run this just normally? Okay, it says it's executed. Yes, so it has produced the output. So let's use this output now. So I think now I have the entire command on hand. So what I will do is I will start from 10 to the power. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I will go up to 10 to the power 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. A lot, big input. So yeah, so C out and then a space. And let's run this. It will be a big file. A very big file, I'm guessing. Maybe this was not a very good idea. To the power 12 numbers. No, not a good idea. This is minus I will do this only. Wait, Control C. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Minus, let's say 1e5. So only 10 to the power 5 integers. The terminal is stuck. 10 to the power 5 outputs, I think it should not be a problem. Okay. Okay. This will go into the 1, 5, 1, 2, 3, 4, 5. This will be the input. And now I want that file, the P6. Right? So for this, I want this to be defined. That's the P6 guy. Yes. Yes, I want this to be defined. And so, and yes, that is, there will be test cases. So run this, let's say. P6, right? P6. Let's see how much time it takes. I have to put the time command. Okay, 1.4 seconds to run 10 to the power 5 test cases. And those are all big. I think we can conclude that what is the maximum one digit can take, right? We are already considering the biggest digits. Can we output 10 to the power 6 digits? 10 to the power 6 digits. Yeah, how about 10 to the power 7 digits? Too many digits. Considering that we will only consider one for the final solution. Okay, 10 to the power 7, it's also working. So 10 to the power 8 digits. That should take at least 1 second by C++ standards. Yes, so 10 to the power 8 digits we have now. Right? Yes, so a very big file. How much file? Let's just see how much file. It doesn't matter. Anyways, so it's a 10 to the power 8. This is 10 to the power 5, 6, 7, 8. So this is 10 to the power 8. So it's around 30 megabytes. So we will use this on the P6 file. Yeah. And we will also time it. So 2 seconds. Wait, it's still running, is it? Still 2 seconds. Let's run it again. For 10 to the power 8. I think it will pass for any 10 to the power 12 based. Now I think we can conclude. I think I will just save this in some template so that I can regularly use this input output in file part. So Control C and just make a new snippet. File input output. Yeah. This will be handy later on. Anyways, let's go to the next question. It says 120 LeetCode. So we will be solving the 120 LeetCode. problems. Okay, it's a medium question. Let's see what it says. Okay, how long is the stream running for? It's only 2 hours. I hope I am visible. What it says. Yeah. Okay, how long is the stream running for? Okay. Given a triangle, return the minimum path from top to bottom. Okay, it's a simple triangle. It looks like a Pascal's triangle, but with different numbers. So minimum path. So we can only go this way or this way. Okay. I think this is a very simple DP based question. I think since if you have watched my DP grind part 1, part 2, part 3, this should be very easy. I will still explain you my thinking. I think I can close this off. Where's the iPad? Yes. Okay. So let's say we have this triangle. A, B, C, D, E, so D, E, F, G, H, I, J. You understand that if this is IJ, so I mean ith row and jth entry, it's dependent on I plus 1. So J and I plus 1, J plus 1, sorry, J minus 1 and J. For example, this is 0, 0, this is 0, 1, this is 0, 2, sorry, this is 1, 1, 1, 2, 2, 1, 2, 2. Well, let's make it clear. 0, 0. So 0, 0, 1, 0, 1, 1, 2, 0, 2, 1, 2, 2, 3, 0, 3, 1, 3, 2, 3, 3. You see that 2, 2 is dependent on 3, 2 and 3, 3. So one more in terms of rows, and for the columns, it's the same and one more. I hope you understand. Okay, 0, 0. Okay. So if I start from a particular row, I want to know the minimum from I plus 1, that, and I plus 1, that plus 1. Okay. So let's say int rec, it will take int I, int j, and of course the triangle I need. I want to know the minimum cost path. It will be this plus whatever this subtree gets me, or this plus whatever this subtree gets me. Like, let's show it on the iPad. Like, it will be the answer. Let's say I want to know the answer for 2, 0. That will be the answer for, that will be the element on 2, 0 plus the minimum cost path from this to the end, or this plus the minimum cost path from this to the end. So the 0, 0 will be the element on 0, 0 plus the minimum cost path from 10 to the end somehow, plus 1, 0 to the end somehow, or the element at 0, 0 plus world from 1, 1 to the end. So either I can come from 1, 1 or I can come from 0, 0. Okay, so ij, so return triangle of ij plus recurrence I plus 1, and I think I should do I plus 1j. So 1j, let's say this, call this comma recurrence, sorry, this part I plus 1, I think j plus 1 will be there, yeah, plus 1 triangle. So the minimum of these two. But if we have reached the end, like if I equal to like the triangle size is 1 2 0 1 2 3, right? I mean the number of rows is 3, so if I is anytime 3, equal to let's say triangle dot size minus 1, size minus 1, that means we are in the last row, so we just return the triangle of ij. Of course we will memorize this, right? So we just want the answer for recurrence of 0 0. I just pass in this triangle. Let's see if it works for the sample cases. Okay, it's fine. Directly, no compile time errors. Let's try to submit this. This will give a TLE, I'm sure. Even though n is up to 200. No, it will be exponential still. 2 to the power 200 is very high. It should give TLE. Because it's dependent on 2 states. So 2 to the power 200. Right? Yes, TLE. So now we will memorize this. Extremely easy, only 2 state dependent, so we will use dp, and we will need, okay, how many states should be there should be in dp, like let's make it, should I make it a map, like 200 by 200, it's not a big number, so I can make it full size. Triangle dot size by triangle dot size. Okay, and I think I need a same for visited. We used to use the, yes, I can do minus, but no, but the answer can be up to negative 10 to the power 4, so visited is the best. Or you can use a 10 to the power minus 10 to the power 5 as the default value, but so this would be a bool. Okay, so now you'll also pass this dp and vis. Of course I will need this too to be inserted here. Of course, before, I think I will need this. And I will need this. Okay, a lot of stuff. So before just returning, I'll just say dp of ij equal to, and before returning I will just say that if not, okay, I mean if not if visited, I mean visited of ij, return dp of ij. Let's see. Okay, it says that cannot be initialized with multiple values. Triangle dot size, comma. Okay, first this will not be references. Okay, let's try submitting this now. So we just added a memoization step, nothing rocket science. TLE again. Okay, I have to mark visited, right, before returning. To one, right? Now I can submit. Yeah, it's the same. I just, yeah. Of course, there is a bottom-up approach as well. Like in the last row, I know the answer. I can start from the second last row, and for every element, I will take minimum of the first and the second, and I will make it. In the next one, again minimum of that and that, make it. So from the second last row, I can build it up to the first row. Let's try to do that solution. It will be bottom up, even though we have not done any bottom up stuffs in our DP grinds. We mostly focused on thinking about recurrence and how to memoize. Of course, I will try to explain bottom up stuff all together. Like if you have a recurrence, I will try to explain the push way, the pull way, how to convert any recurrence to a bottom-up approach. And of course it will, and also that it's complemented with the idea of space optimization. Like if you see something repeating and not being dependent on an entire blob of stuff, you can just do space optimization. So I will try to club that up together. Let's keep our discussion to thinking about recurrences and memoization for now. Okay, let's go to the next question. Given an array containing two binary strings, you want to return the maximum sum. So you just have two binary strings, add them up, and add all of them up. Whatever maximum you get is the answer. That's it. Nothing rocket science. Either, of course, you can use a library to convert this binary numbers to a decimal to add them efficiently and maybe calculate. Or I think using libraries is the best option. Or you can take a 2 to the power 0, multiply with 1, then 2 to the power 1, multiply by, I mean, the binary digit into 2 to the power 0, next binary digit 2 to the power 1, multiply and then add. Of course, there is a manual way. Let's go to the VS Code and solve this. It will be P7, I guess. So in 10, so we have just pairs of size n, We just input. So we're given binary strings, right? 101. Can we copy from here? No. 101, 100. Wait, where am I? 3, 101, 0, 110, 10. 1011. Okay, so we have 3 numbers. So I think there is a way. Let's try to, let's say for int u is equals to, I think, convert binary string to decimal number. Binary string to decimal number. There are some this is the manual way. There's some, yes. So I think I will use this. I should not go ahead long now. These are string by the, oh sorry, BP vector, a pair of string and string, right? Yeah. But we want the final result to be in binary as well. I think there is a formula of res dot to binary string, integer to binary string. CPP. Yeah, I think I heard about bit sets. Okay, I think there is a, I have a template. So how much size do I want? Wait, where are the functions? Okay, bitset dot size. Let's say 5. Let's erase. What does this print? I think it should be 0, 1, 0, 0. What is it? Line 86. How do I print? wait, yes. Let's just do a C out. Maybe not happy trying to. Okay, vector a pair of string, I think it's okay. Yeah, so I want the what is the let's say it's 31 size, 32 size. But we want to start from the first non-zero, right? Like we don't want preceding zeros. Is there a function for that? Even though this part can easily be done, you can just really see that, like variable name of I comma 31 0 if bits of I is not equal to 0. So first non-zero I find k is equal to 32. K is equal to I, break. Size underscore t will work. Yeah, that's the problem with bit sets. They want normal size. Okay, if that's the case, then ff I comma key comma 0 c out bits of I and no space. Right. Yeah. Okay, received out nothing. Okay, print k. K is 3. So okay, this should be fr. Right? Okay. So this is probably a way. So it's just we just check for the first, find the MSB basically, and print from the MSB to the end. I hope I made myself clear. Let's go to the next question. Okay, you are given a string consisting of lower letters. It can duplicate or non-duplicate. So you just say that what is the first letter? Wait, okay, these are inputs and outputs to different questions. That's what I thought. So you return the index of that character which has which is unique basically, right? So it's just a very simple question. So I just go through every character, make a map out of it, and let's go through it again. Uh, if it is only present once in the map, output that. Nothing rocket science. So this is the P8, right? P8. So I input what? A string. That's it. Statistics, right? Yeah, expected. Too easy. Let's go to the next question. You're playing a card. Okay, that I think was the yeah. So you're in a starting list, and we want to know that from the given index, if I want to reach yellow, so in the given index is blue, right? In the first input, let's consider the given index is blue. I can either go green, yellow, or I can go red and yellow. It's circular in nature. Next, it's from 3 I want to reach black. So from red I want to reach black. So I can go brown, gray, black, or I can go pink, black. Okay, so I just have to find the index of the result. I think all of them are unique. Yes, all of them are unique. And we want to find the index. I want to first we find the index of the result, and then we check two distances. One, if I go from start, I will check that where my end is. If it is before the start, one answer is start minus end plus 1. The other way is start to end, and then from first to the destination. I will explain more as I code. So we are given an array of strings, right? Red, blue, green, yellow. We want to find the minimum distance basically. So P9. So we also input int start index and string end. First we check so I will just index equal to okay. So we found the end index, we know the start index now. So there can be two possibilities. One is start index is after end index, or start index is before end index. Doesn't matter if it is before or after. One distance is just end index minus start index plus 1. The other way is just from start to end. But what if end is after start? And we don't want that. So first to start and then end. First to start index and end index to end. Okay. So int direct result goes to end minus start index. Wait, let's see from the question. Like the direct answer from 1 to yellow is so 0 1, and index of yellow is 0 1 2 3. So 3 minus 1 2. That's the first step. What about now? You check if end is index is greater than start index. If end index is greater than start index, that means the first distance, it can be direct. So well, let's say result. So result equal to minimum comma. So I will do n minus end plus start. Okay, right? I will take care of boundaries later. Else if end is less than start, so in that case I will do this like end is less than start, so from end to start and plus end index, and we just print the result. Of course I have to take care of boundaries first. Let's try inputting something first. Well, let's check the boundaries anyways. So let's say we have the code red, blue, green, yellow. Red, blue, green, yellow. Okay. So this is the start. So 0, 1, 2, 3. This is the end. Okay. So one way is end is up, end minus start. Okay, I have to do the absolute. Allow absolute. Okay, so one way is that. The other way is, since start is less than end, what is the distance I have to jump? 1. So 1 from the start, and from the end I have to do n. I don't have to, I think I have to jump 1 more, right, in order to reach this 0. So 4 minus, so that is n minus n plus the index of start. Yeah, it should work. The same way the other one also works, which is the distance. So let's run this. Okay, I have to input. So 4 and then I think I have to input 4 strings. So just red, blue, green, yellow. Then I have to input, I think, the start index, so that is 1 in my case, and the final result, so yellow. The answer should be 2. It's sick part. Just forget this. It is causing sick part, like if v of I equals to end, like if it's a string, okay, I have to input n. That is probably a null string. Okay, can I print this, all of these, like print okay, we get a null string. Okay, I have to, this is of size n. Yeah, okay, now it's working. So yellow was the end string, by the way. So yes, 2. Let's do the second test case. Black, gray, brown. So BL, GR, BR. It was 5, like BL, GR, BR. REPI. Okay. So we were on pink, right? We were on pink, so 1. No, we were on what? We were on 3 black. So there are 2 kinds of distances possible. It's 2. Yeah, so basically I start from red to pink, pink to black I go. I don't go this way. The constraints are extremely small, so it's a very easy question. I hope you understand. Just take care of these indices. Think about what you are subtracting them. Sometimes there is a -1 or a +1 somewhere, trying to convert from indices to real world distances and jumps. And that's all there is to this question. Of course, I have to remove this printing the end part because they really don't want that. They just want the distance. Okay, that should do it for this question. How long has the stream been running? 2 hours 41 minutes. Is it running well? Let's check. And that's all there is to this question. Of course, I have to remove this printing the end part because they really don't want that. They just want the distance. Okay, that should do it for this question. How long has the stream been running? 2 hours 41 minutes. Is it running well? Okay, let's get started with the next question. It says 2895 LeetCode. Okay, count negative numbers in a sorted matrix. I think we did this. No, just did this. We are going to solve 2895, right? No, so not this. 2895. I don't want any filters. is minimum processing time. That's what we are searching for. See, you have a certain number of processors, each having 4 cores. The number of tasks to be executed is 4 times the number of processors. Okay, I think there is some parallel execution. Each task must be assigned to a unique core. Okay, and each core can be used once. So you are given an array processor time representing the time for each processor. Okay, processor time is 8 and 10. So I think that the output is 16, right? Okay, I understand. So it's like, what the time? 8. Let me just copy the question and I will get back to iPad. And 2, 2, 3, 1, 8, 7, 4, 5. Okay, let's go back to the question. Where is the iPad? Yeah. So let's say the processor time is 8, right? So I will try to assign this the biggest ones, so that let's say 7, 4 and 5, right? Let's see if I assign 8 to this and also 7, 4 and 5, the 4 big guys. So there are, the processor execution time is 8. So 8, 7, 4, 5 will go to this processor together. And 8, in order to execute 8, will take 16 time. 8, in order to process 7, will take 8 plus 7, that is 15 time. But 8, 7, 4, 5 are running in parallel on the processor that itself takes 8 times, time 8 to execute. So we will try to club the minimum people with the processor that takes the maximum time, so that the sum is minimized. I hope you understand. And it's all pairs of 4, so there is no interoperability problems. So that's it. So I will just sort this array, sort. So, and I will reverse sort the processor array. So the big processor time, small tasks. So that will help me greedily get to the minimum time. So sort reverse processor time, and sort tasks. Of course, all and roll have to be defined. Roll means processor time dot r begin, comma processor time dot r end, and all means tasks dot begin, comma tasks dot end. Okay, you can look it up. R begin, R end, begin, end, C++. Basically iterators, nothing rocket science. Now we go to equal to 0, I tasks dot size I can just processor time dot size. So 1 is responsible for 4, right? So I think if I do a mod 4 on like if I take a ceiling division with 4, like 0, 1, 2, 3 divided by 4 are all zeros. So that will be assigned to processor 1. 4, 5, 6, 7 divided by 4 is 1 floor division, of course. So that will get to the processor 1. 8, 9, 10, 11 by 4 floor division is 2. So if I do tasks dot size, and even the tasks are if I do processor time, can I say that 0 will be responsible for the 4th task? So I0 means 4, I1 means 7, so 4i minus 1, right? But for 0 it is just 0 into 4 minus 1, 0 into 1. So 4 into I plus 1 minus 1. Four into I plus 1 minus 1, right? So this is the index. Plus processor time of I. I'll tell you what I'm doing. It's just I'm taking the 4th task for every. Okay, I have to define this role and all. $29. So it's like 1, 2, 2, 3, 4, 5, 7, 8. First I'm doing tasks of, I want tasks of 0, 1, 2, 3. So 4 into 0. So 4 into 1. 4 minus 1 is 3. Task of 3 plus processor time of 0. Yes. Then it's I equal to 1. Printer is okay. What is wrong with this? Okay, one more. First the range is 13. 8 plus 3, but it should be 11, right? Okay, all so I want the maximum time to be allocated for the minimum task. So 10 plus 3, 13. Good. And 8 plus 8, 16, right? 16 plus 13 is, and I want minimum time required. Okay, all the tasks work together, right? So max. Okay, so all the processors are parallel execution. It's not like that one core is working and not. Where's the tasks gone for some? Okay, this should do it. Very easy solution. It's think about. Okay, let me show you what do I mean by that 4i minus 1 plus 1 thing. So this is the sorted array, right? I'm only interested in fourth guy, every fourth guy, because I know that every fourth guy will be bigger than the last, the previous three. So processor time of, let's say, X is being assigned to this block. What is the maximum time of execution? Is the biggest plus X. That's why, like, this is for 3 index, this is for 7 index. So the for first processor, it's 4 into 1 minus 1, which is 3. For second processor is 4 into 2 minus 1, that is 7. That's how I am calculating this. And that's all there is to this question. You can look at the code once more, pause and maybe think about it a little bit. That's all. Let's go to the next question. Okay, first see how long the stream has been running. Almost 3 hours. Let's do the next question. Next question says you are given a string and I am told to perform a particular query. So find the length of this lexically smallest suffix. So this can be solved, like, the constants are not clear in this question. It just says size n, but there are a lot of queries. If it is asking for modulo 10 to the power 9 plus 7, that means I want the queries to be of, we don't want an n cross q type of answer. So what we can do is maybe use a KMP to find the to see if that pattern, what is the last time this pattern has occurred in my string. So n minus that is the length of the suffix. So for example, let's say this m, z, a, d, p, o, g, h, y, this yk is, you see, YKHT. So YK may appear before as well, but we want the lexically smallest suffix string. So we want them to be smallest, right? So from the we will check, try matching patterns, find the last index where this element, this string has been, this pattern has been found in the string, and n, which is the length of the string, minus the index of occurrence, is the answer for that particular query. I hope you understand. Let's try solving this. I will use the KMP template. Even though I should not, because I have not explained you KMP yet. This brute forcing is an option, but I don't think they expect us to do the brute force. Because whenever I see this modulo 10 to the power 9 plus 7, that means they are expecting big strings and a huge number of queries. And okay, let's start. Or should I skip this question for later? So either you know KMP and you will implement this very easily yourself, or it will cause a TLE. It will pass for some of the test cases, but not a lot. Let's see how many questions are left. 1, 2, only 2 more questions are left. Let's the next 2 are just LeetCode, so 501 and 485. Let's solve these 2 for today. The string is running very long, so it has been 3 hours already. Let's solve these 2 LeetCode questions. Maybe tomorrow I will start with this question, AMP, and we will start with the LRDP part. Or maybe I will take a separate day for teaching this string based, or rather explain and learn along with you. So I will take a separate day for strings after these DP grinds are over. Okay, so let's fix the orientation. Let's do these 2 LeetCode questions. One is 50501 and 485. find mode in a binary search tree. And the next is I think 485, right? So it first follows that property that every element less than equal to that and given the tree node, it just expects me to find two like vector of element. So we just do an in order traversal, find all the elements. We will get them in sorted order if we do an in order traversal in a BST. We will check the frequency of every element. Of course, check that which one is the maximum frequency, and whatever elements are with those maximum frequency, we push it into a vector and return the answer. So I can just say void in take the root if root equals to null pointer, even though return if root is not a null pointer. So I will just push it into the vector. I can keep a vector of elements. So otherwise it's dot pushback I think root dot val, right? And let's say if right is not equal to null pointer, I'll just call in with root arrow right. Let's do in of root and lms. Let's just see what the output is if every element is there in the LMs. Okay, so we have 1 2 2, next case 0. So yes, expected. So we can just map MP for x through LMs MP of x plus plus int max fix equal to 0. So what? Okay. So basically we are putting the elements in a set if that element occurs how many times? Element occurs maximum frequency number of times, then we just say that okay, that is an acceptable mode. Even though some of these checks are not required, but like if root is equal to null pointer, this will not come unless the question comes with a null pointer. We can just check that in my find mode function because we are only calling root arrow right if it is not a null pointer. So there cannot be hope you understand. Try to think about this, that when am I going to face null pointers. Okay, let's go to the next question, that is 485. I hope my stream is running well. Going to face null pointers. Okay, let's go to the next question, that is 485, right? Okay, this is an easy question and I have solved this before. Okay, this is just a very simple question. I think I've recently solved it. It just says that return the maximum number of consecutive ones. So you just loop through the array Okay, let's solve this. So what we do is, if I find a 0, I reset my count to 0. If I find a 1, I increase my count. And also update the max count. I mean, try to update the max count. Like, let's say there is a 1, 1, 0. First one, increment. Second one, increment. 0, make it 0. Next, increment. Next, increment. Next, increment. And done. Every time I increment, I will try to update the max count. Like 1, max count is 0. Let's make it 1. 2, max count is 0. Make it 2. Sorry, max count is 1. Make it 2. So I'm talking about 1, 1, 0, 1, 1, 1. This first test case. So that's what we are doing. So for, I think I can just get back to my submissions. I don't want to waste time writing the code. It's exactly what I just said. Like, every time I find a 1, I increment the count and try to update the max count. If I don't find a 1, that means I found a 0, because it's a binary array. And we just return the max count. That's it. I hope you understand. Let's keep it up to here. We have missed only one question, the string matching one. If you are solving this in basic service-based companies, they don't expect you to know, I mean, they should not expect you to know KMP and all. If you are applying for fresher. And I hope to not implement KMP there without any templates and all. It will be considered a hard question in my opinion, if they expect me to know KMP. But that thing aside, you should know how KMP works, how the LPS works, how to calculate LPS in order of size of the string. Okay. We will take a session on strings. I have it planned sometime, maybe not in this year, only few days left. We will be focusing on DP grinds. We have already completed 3 parts. Today I thought maybe let's go over some general concepts and general questions from like solving this small sheet. Of course, after the DP grinds, we will be doing a graph grind. We will try, but I don't want to promise anything as of yet. Let's see how it goes. I plan to solve every DP question, at least all the medium ones and the important hard ones, DP questions, then all the graph questions, all the easies and all the mediums and some hard. Like, I believe that medium is and some hard questions are the ones one should target. Hard questions are rarely asked unless it's a very big company like quants and all. I hope. I think I should keep it here. Thank you very much for watching. Like, share, subscribe if you find any value in this channel. We will post different grinds solving lead codes. I have planned entire sheets being solved with explanations so that you can better prepare for placements. I am also a student in that journey as of now. So learn while explaining and maybe you will find some value. Okay. Thank you very much for watching.